Hi, sorry. My name is Claudia Kemp, and this is Module 3, Chapter 10, Length, Area, and Volume lesson. Number 1 gives us a gill on the left and cup on the right and asks us to determine how many mouthfuls are in each of these measurements. A gill is made up of 2 jacks, which each jack is made up of 2 jiggers, and each jigger is made up of 2 mouthfuls. So we can see that we have 8 mouthfuls in a gill. A cup, however, is made of 2 gills, so that's pretty easy to figure out, but we're going to walk through it anyways. So a cup is 2 gills, which means it's 4 jacks, meaning it is 8 jiggers, meaning it is 16 mouthfuls. Now a pint is even easier. It's made up of 2 cups. We already know that a cup is 16 mouthfuls, so a pint equals 32 mouthfuls. Part B of number 1 gives us a pail shown by this purple rectangle here and asks that we put in 1 gallon, 1 bottle, 1 quart, 1 pint, and so on. So we put in 1 gallon here, and then a bottle, a quart, a pint, a cup, a gill, a jack, a jigger, and a mouthful. And it asks, is the pail overflowing? Is it filled to the top? And the answer is there is enough room left for 1 mouthful, as we can see here. Number 2 asks that we define the area of these triangles and the perimeter too, but we'll start with the area. The area of a triangle is defined as 1/2 base times height. So you have the base of triangle A as 80.7 meters and the height 41.0 meters. You plug those two numbers into the equation and find that the area is 1,654.35 meters squared. It's meters squared because it's meter times meter instead of meter plus meter. Moving on to triangle B, the base is 81.6 inches and the height is 34 inches. Plug those two numbers in and we find that the area is 1,387.2 inches squared. Triangle C, the base is 5.8 centimeters and the height is 2.8 centimeters, which we know by the arrows to the left of it, indicating that it's the height of the triangle. Plug those two numbers in and find out the area is 8.12 centimeters squared. Now, perimeter of a triangle is just side plus side plus side added together. So we have 49.5 plus 69.5 plus 80.7 equals 199.7 meters, and it's just meters because it's addition instead of multiplication. Triangle B, 34 inches plus 81.6 inches plus 88.4 inches equals 204 inches. And then triangle C, we have 3.1 centimeters because 3.1 is the measurement of the side rather than the height. And then we have 7.2 centimeters and 5.8 centimeters added together. We find that the last perimeter is 16.1 centimeters. Number 3 gives us this figure here on the right and asks that we determine if the area of the smaller circle is equal to, smaller, or larger than the area between the two circles. So first we have to find the area of the circle. An area of a circle is found pi times radius squared. Well, the radius would be half of the width of the circle, you could say, and so that would be 5 units. So we would plug 5 in for r. We would get 25 pi for the area of the circle. And then to find the area between the two circles, we would form an imaginary triangle right here and use the Pythagorean theorem. Well, since it's only halfway and halfway, the halfway mark would be 5. So you'd fill in 5 for A and B. And 5 squared plus 5 squared equals r squared. R squared equals 50, so the area is 50 pi units squared. So we have to find the difference between the two, right? That's what we were asked to do. So 50 pi minus 25 pi equals 25 pi units squared. Therefore, the area of the smaller circle is equal to the area of the region between the two circles. Number 4 gives us this figure here on the right and asks that we find the area, or no, the volume, I should say, of all of these figures and shapes within this one shape. So it tells us that the radius is equal to r and the height is equal to 2r. First, we need to know that the volume of a cone or a pyramid is defined as 1/3 base times height. The base of the cone we know is the area of a circle, which is pi r squared. We already learned this. So we would fill in these two measurements that we already know for the volume of this cone particularly, and we find that it is 2/3 pi r cubed. Moving on to the cylinder, the volume of a cylinder is base times height. The volume of this cylinder is 2 pi r squared, just plugging in all of our values. The volume of a sphere is defined as 4/3 pi r cubed. Since this radius is already r, then the volume of this sphere is the same as the normal sphere. Next, we are asked to compare the measurements, these volumes, to the volume of the cone itself and give a ratio comparison between the two. So we would just divide them by the cone. So a cone to a cone is a 1-to-1 ratio, because anytime you divide a number by itself, it's always equal to 1. And then the sphere to cone ratio is 2-to-1, dividing that one. And then the cylinder to cone ratio is a 3-to-1, dividing that one with the cone. Number 5 asks that we find the surface area of this shape and another shape. So surface area is 2b plus p times h, the b being the base, p perimeter, and h height as normal. First, we need to find the base. The base is 1/2 times a plus b times h. The a and b would be two sides, and the h is height, as always. So we would have 1/3 times this side, which is 23, plus this side, which is 18, and the height, which is 12. And we find that the base is 246 centimeters squared. And then next we find the perimeter by adding all the sides together, and we find that the perimeter is 66 centimeters. So we go back to this equation here, and we plug in all of our numbers that we found, and we find that the surface area is 822 centimeters squared for this figure here. Moving on to this figure, we can see that the base is not a trapezoid, it's a triangle. So that will change things up a little bit, but the surface area equation is the same. The base equation, however, is a little different. It is 1/2 base times height. So we have our base, which is 12, and our height, which is 5. And we plug those numbers in, and we get 30 meters squared for the base. And then the perimeter is always just adding all the sides together, and we find the perimeter is 30 meters. So we plug it into the surface area equation, and we find the surface area is 270 meters squared. Number 6 asks that we find the volume of this shape. So we can see that these two hemispheres right here equal a full sphere, and the volume, how to find the volume of a sphere, is 4 pi r squared. So we would do 2 pi r h, and then we would add those two together, and we would have 2 pi r h plus 4 pi r squared, which we would plug in all of our known values. The radius would be 4.5 because it's half of 9, which is the full width of the circle. And we would add all of these together, and we get 848 feet squared for this portion of the shape. And then we would work on the cylinder, which would be 4/3 pi r cubed plus pi r squared h. And we would again plug in 4.5 for radius. And we would find that the volume is 1,718 feet cubed. And that is the total volume, adding up all portions. So the cylinder, the sphere, all together, and then the volume plugged in, and it's 1,718 feet cubed. And then we have this shape, which actually has a cone on the top and a sphere and a cylinder, my bad. So for the cone, we would plug in these numbers here. So we would have pi r squared plus 2 pi r h. And then we'd also add in the volume equation for a cylinder. We plug in all of our known numbers here, plug in 2 for radius, and 12 for height, and 6 for slope, or S. And we would find that the volume is 201 meters squared for the second figure. No, my bad. Surface area is 201 meters squared. The volume has still yet to be discovered. Sorry. So the volume is defined as pi r squared times h1 plus 1/3 pi r squared times h2. So h1 is 12 over here, but h2 needs to be discovered, and it is the cone, and we just need to use the Pythagorean theorem of sorts to find it. So then we find that it is 5.66. We would plug that in for H2, plug 12 in for H1, and then 2 again for R, and find that the volume is 174 meters cubed for this shape. Thank you for watching, and I hope you learned something new.